Hello friends, welcome to this tutorial. Here we will discuss on LeetCode problem number 1912, which is design movie rental system. Let's go to the description of the problem. So here we need to design a movie renting company, which consists of n shops. Uh, so here we want to implement a system that supports searching, booking, or returning of the movies, right? So each movie is given as a 2D integer array entries. So here you see, right? This is our constructor, and here we have this 2D arrays entries, where entries of I will have the value like shop I, movie I, and price I. Indicate that there is a copy of movie at shop I with a rental price of this. That means that the shop has this ith movie, and it can be rented on this price P, and each shop can maximum carry at most one copy of a movie. Okay, now we want to implement these following functions. So first one is search. So this search function, so here we need to return the 5 shops that have an unrented copy of a given movie. So here we have the input parameter as movie, and we need to return the cheapest 5 shops which has the unrented copy of this movie. So the shop should be sorted by price in ascending order. Of course, since we need to return the cheapest, so it must be in the ascending order of the price. And if the price is same, then the smaller shop I should appear first. If there are less than 5 such shops, then we will return all of them. And if there is no shop, then we will return an empty array. Okay. Next is the rent function. So here we will need to return a unrented copy of a given movie from a given shop. So here we will rent that unrented movie from the shop I, right? And then there is another drop function which will drop the previously rented copy of a given movie at a given shop. So we have this input parameter shop and movie. So this movie of the movie of this shop which we have rented previously, now we will drop off. So it will come into as unrented now. Next one is this report function. So this report function, here we will need to return the cheapest 5 rented movies. Now, cheapest 5 rented movies, okay? The first one in the search, we are returning the cheapest 5 unrented copy, and here we will need to return the cheapest 5 rented movies, where movie of I, so it this resultant vector will have this value like shop J and movie J, describe that jth cheapest rented movie was rented from the shop J. We need to return the movies in such a way that it should be first sorted by price in ascending order. And if there are two combination with the same price, then the one with the smaller shop should appear first. And if the shop is also same, then one with the smaller movie should appear first. That's how we need to implement these functions. Let's go to this example to understand it more. Okay, so here we have first this movie renting system, and it has an input parameter as 3, which 3 here is means the number of shops we have, right? So we will say that number of shops is equals to 3, and then we will just have this movie rent entries, right, which contains the shop value, the movie, and the price on which this shop will rank this movie at this price, right? So let's create one storage where we will have this unrented copies, right? So first one is this. Okay, we inserted this. Then second one is this. Third one is this. Sorry, this is the fourth one. Or let's do one thing. Let's just copy this entire thing. Now we will create one unrented movie storage. Okay, so movies, how many movies we have? First is this movie one, right? The first movie. Now, what is the price? It has the price of 5 and it is shop 0. The shop 0 and price 5. Or we will first store price and then the corresponding shop. Okay, now this, do we have another movie with one? Yes, this one, right? It has a price of 4 and shop 1. So we will store like ascending order of the price. So 4 will come first here and then 5 comma 0. And similarly now this has a price 5 and the shop is 2. So price is 5, shop is 2, that means it will come here. Now let's go to movie 2, right? So it has the price of 6 and the shop is 0. Then again we see, do we have any movie 2? Yes, it has a price of 7 and shop as 1. Then we have the movie 3. So it has a price of 7 and the shop corresponding shop is 0. That's how we have the unrented movie storage, right? Now we are done with this. Now our next input is this, which is search. So here search has the input parameter movie and we need to return the cheapest 5 shops which will give us the movie in smaller prices, right? Lower prices. So here in the search we have the movie input parameter as 1. So we will need to return the cheapest 5 shops which will return like 5 shops which will return rank the movies in movie 1 in cheapest price. So this is the movie 1, right? Now we see that we don't have any 5 shops here. There is only 3 shops, right? So the shop 1 will rent on price 4, shop 0 will rent on price 5 and shop 2 will rent on price 2. So our answer of that will be we will need to return in ascending order of the price. So shop 1 will come first because it is returning in lower prices. It is renting the movie in lesser price, right? Then we will see that both shop 2 and shop 0 is renting the movie on same price, which is 5. So we will return the shop which is smaller. So here 0 is smaller, right? So we return that and then 2. So our answer will be here 102. Now again there is a function of rent. So we will rent one movie. So let's create one more storage which is rented movie. Okay. Now here rent. So here we have the input parameter as 0 and 1. So we will rent the movie. We will rent the movie 1 from shop 0. Shop 0 movie. So it contains like this shop, comma, movie. Okay, so we rented the shop 0 movie 1. So you see here, right, that this particular movie 1, this shop, right, the 0 shop is now comes under rented. So we need to remove here. We will remove the from unrented and then we store it here. right? Again, there is a rent of movie shop 1, movie 2. So, movie 2 and then shop 1. So, this also got removed and we will add. Let's store the prices as well over there. So, shop 1, movie 2, and that has a price of 7. Similarly, here the shop 0, movie 1 has a price of 5. Okay, now again, now there is this report. Okay, so in the report, what we are doing, we need to return the cheapest prices. First, we will need to return the rented movies with ascending order in their cheapest price, right? And then if the price is same, then the one with the lower shop value. If the shop is also same, then the one with the lower movie. So here we see that in the rented movie, we only have two two movies or two movies which are rented by this shop, right? So here maximum value we can return is 2 only. So now see, the cheapest price is this 5. So we will return first this combination, which is 0 comma 1, right? And then we will return this, which is 1 comma 2. So this is our answer here, right? Now after rent there is this drop function. Okay, so drop means we will remove this particular movie from this particular shop in the rented movie. From the rented movie, we will remove this movie 2 from the shop 1. So, which is this movie 2 from the shop 1? We will remove this and then again we will add it here. So, we just again add this. Here we are storing like this movie, uh, and then it has a corresponding price, comma shop. So now we added there and we remove from rented movie. Now again we have a search and we want to search on movie 2. So on movie 2 we have the two values here, right? So what we will return, the one with the lower price first. So the lower price is this, the 6, right? So we first return this shop 0 and then we return the shop 1. So that's how we need to solve this problem. Now let's understand the constraint so that we will finalize first what data structure we will use, which will suffice this constraints. So one is like shop is in the range of 1 to 3 into 10 raised to power 5. So there can be maximum of 3 into 10 raised to power 5 shops. Okay. And the entries are have a maximum of length of 10 raised to power 5. Okay. um, Movie and price can be in between 1 to 10 raised to power 4. Okay. And there can be maximum of 10 raised to power 5 calls in total to all these functions. Okay. So like understand, let's go through each functions and we will try to implement uh, and we will choose a data structure like that only. So first one is this entries, right? So we need to this entries like it has the values like shop I, movie I, and the price I. So we will store the movies. These movies as of initially are in the unrented position, right? So we first need to create a data structure which will maintain this unrented movies. So here you see, right? First key is our movie, right? And the value is pair of price and shop. So similarly, we will create this unordered hash map with key as movie and the pair with price and shop. Now, should we use a vector to store this combination of pair and shop, or should we use any other data structure? Remember, we need to store the prices here in ascending order, because that's what we will need to return in the search. So we will use set here. With set, we will be able to store the combination of pair and shop in ascending order. So I will say it as like unrented movie. Now, similarly, we need to store the rented movie. Now, rented movie will be stored like this: shop, movie, and price combination, right? So here also we will need to store that in ascending order. So we will have set of vector of int, right? And it will store these three values: shop, movie, and price combination. Okay. So now let's go here. So we will just do loop through these entries. Okay. So here the shop is entry 0, movie is entry 1, sorry, and price is entry 2. Now, initially, since all the movies are unrented, so we will store this movie here. So the unrented movie, and then we will store the corresponding price and shop. Okay. Now let's go to this search function. What we need to return here, so we need to return shops which the shops which will rentate the movies in the lower prices, right? So we will have one resultant vector. We will iterate through this movie set, right? This unrented movie set. So for auto IT of this unrented movie, first we will check if result dot size is equals to 5. That means we we have identified all the first cheapest 5 shops here, and then we just simply break. If not, then we will push back the shop into this resultant vector, and the shop is so here, right, the set has this pair of informant where first we are inserting the price and then shop. So the shop is it dot second. Now again this rent function. So here we need to rent the corresponding shop and movie, right? Now here we see, right, we are storing the shop price, shop movie, and price. But here we don't have a price information, right? So let's first create one more data structure which will store the price of that particular movie from that particular shop. Now here the key will be pair of shop and movie. But can we store that pair of shop and movie as it is as a key? No, because in C++, by default there is no hash defined for this pair values, right? So instead of storing this as a pair, we will encode this into some integer value, the shop and movie combination, and then we will store the corresponding price. So let's create one that encoding function as well. So we will have like this get key. We first have input as shop, and then movie. Now, how can we encode this into this long value? So we see, right, that this movie, it has a maximum of 10 raised to power 4 character only. So what we will do, we will just first multiply the shop with 10 raised to power 5 character, and then we will add movie, so that it will always be a it will the combination will always be unique only, the movie and shop combination. So we will just do, we will multiply first shop with 1e5, and then we will just simply add movie here. So that's how we will get the key, right? So now here also we need to store this price information, right? So we will have, so we will create one long key is equals to get key of this shop comma movie, and then for this key we will store the price. uh, let's rename it as like this, movie price. Okay, now here as well, now we know that, okay, how to, we first need a price here, right? So int price will be equals to, first we will identify the key value of this. So long key is equals to get key from shop comma movie, and then we get the price value with this. Okay, so now we have the shop, movie, and the price, and we will store that in this rented movie. So rented movie dot insert, first we will store the price, because that's how we need to return, right, in the smallest order of price, then shop, and then movie. Now we added this in the rented movie. Now we need to remove this from unrented movie as well, right? So what we will do, unrented movie dot erase this price and shop combination. Okay, now the opposite way we need to do here. First we will identify the key price value here as well, and then now here we will need to insert in unrented movie, right? So what we will do, unrented movie dot insert, and what we will insert, price and shop, and then we need to remove from rented movie. So rented movie dot erase price comma shop comma movie combination. Okay, now let's implement this last function, which is report. So in the report we need to return the cheapest 5 rented movies. So here as well we will have factor of int result. Okay, we will loop through all the rented movies. So for auto IT of this rented movie. Now this IT has 3 values, right? One is price, then shop, then movie. So first thing is we will check again if the size is equals to 5, then break. That means we get the cheapest 5 values. So we just simply break here. If not, then we will push back this into the resultant vector. So result dot push back, what we need to push back, this shop comma movie, right? So shop is at IT1, right? This is IT0 is price, IT1 is shop, and IT2 which is movie. and then we just simply return the result vector here. Here as well we need to return the result vector. Let's go through, verify the code if there's any error here. So this looks good. Okay, yeah, I think this looks good. Let's run the test cases. Oh, sorry, it's unrated movie of this. We need to traverse, right? Okay, test cases are passed. Now let's try to submit this. Okay, our code is also accepted. Now let's understand the time complexity and the space complexity. So, n is the number of shops, and let am is the number of calls made total, right? So let's understand how many what time complexity each function is taking here. Each line is taking here, right? So first one is this. We look through the entries, this entries vector, and then it has a time complexity can be maximum of this 10 raised to power 5, and then we are doing the insert operation in the set. So the insert in set will take maximum of log n. Okay, and this is also, since we are having this as suppose n entries, so in total it will take then O of and log n. Now let's understand this. So here again we are iterating this unrented movie 5 times only, and then we are just simply doing the returning the resultant vector. So here the time complexity it's constant only because we are just breaking after iterating the 5 elements. So this is O of 1 only, constant. Similarly here, the insert in this set will take log n. Erase will also take log n in the set, right? Here as well, the insert will take log n, and erase will also take log n. Now here as well, this is a constant only because we are just looping it for 5 times, so this is constant. Okay, so now let's think that this particular functions or this particular methods are called m times in total, like maximum time raised to power 5 calls. So the maximum time complexity here is O of m log n. So first one is when the constructor is called. So there we have the time complexity of n log n, right? When the constructor is called, plus when these methods are called, right? So this is maximum has O of m log n. So total time complexity will be O of m plus m log n, right? So that's how we solve this problem. I hope you understand this particular method, the way we are solving this problem and the way we have calculated the time complexity. So space complexity will also be like we have a maximum number of movies can we have is like 10 raised to power 4, and then for each corresponding movie we are storing the corresponding set shop value, right? So this will in total take O of n, right? And this will also take O of n, and this will also take O of n. So space complexity here is O of n only. So yeah, um, I would request you to please solve this problem by yourself. I first understand how we solve it, but then please try to code it yourself and try to solve it, and also try to debug like how we are calculating the time complexity and the space complexity as well. So yeah, that's how it is. If you like my video, please do like, share, and subscribe. Yeah, thank you. See you in the next video.